morning, I am Jhalak and I am here to demonstrate an experiment to find the coefficient of thermal conductivity of a bad conductor by lead disk method. The materials required are lead disk apparatus, which consists of a metallic disc resting on a deep hollow cylinder of same diameter, a circular disc of the specimen of a bad conductor, a stopwatch, two thermometer, boiler, heat, screw gauge, and 1-year caliper. We are going to do this experiment on virtual lab. Here in VLab, we have a steam generator, a steam chamber, lead disk, which is our lower disk, and an insulator, a stop, and also a stopwatch. We can select the material of the lead disk from here, which in this case is aluminum. We can change the lead disk height. I am taking 1 centimeter, and we can also change the radius of the lead disk. I am taking it to be 4 centimeter. Then we will select an insulator. We can select any of the three insulator. I am selecting cardboard. We can select the thickness of the cardboard. Now we will place the insulator. The insulator is placed between the upper disk and the lower disk. The thermometer T1 is measuring the temperature of the upper disk. The thermometer T2 is measuring the temperature of the lower disk. Now we will start the steam. The system is allowed to get heated till both the thermometers attain a constant temperature. The temperature T1 and T2 are recorded. Now we will remove the insulator and let the lower disk get heat up to the upper disk temperature T1. Now we will stop steaming and start our stopwatch, and we will click show graph. The lower disk is cooling down to the room temperature, and this graph shows the plot between the rate of decrease of temperature with respect to time. The slope of this graph will be the rate of change of temperature with respect to the time. You can see the graph is getting constant here. As the lead disk is reaching the room temperature, the temperature is not changing with respect to time. The time is increasing, but the temperature isn't increasing. We will stop the timer and we will take this graph. In physical lab, we obtain an observation table by noting the temperature at different time. A graph is obtained using the observation. The temperature is plotted at the y-axis, the time is plotted at the x-axis, and the slope of the rate of change of temperature with respect to time is obtained. The M is the mass of the metallic disc. C is the specific heat of the metallic disc. The D, capital T by dt, is the rate of change of temperature with respect to the time, which is the slope obtained from the graph. X is the thickness of the insulator. T2 and T1 is the initial temperature of the upper disk and lower disk. R is the radius of the lead disk. H is the height of the lead disk. From all the values of M, C, the slope, X, T2, T1, the radius of the lead disk and height, we obtained our K. And that is how the experiment is performed. Here are some points to remember. The Lee disk experiment determines an approximate value for the thermal conductivity K of a poor conductor like glass, cardboard, etc. Rate of energy transfer across the sample can be increased by keeping x small. X is the height of the Lee disk and A large. A is the area of the Lee disk. Thank you.